Hi everyone, welcome to another BLENDERSUSHI live noding session. Today we'll be talking about a big topic, but it's actually also my favorite. It's animation. And animation topic, I was actually thinking to make like a whole lecture animation 101, um, and I even write down what I was trying to talk about, but then I realized it might take like 2 hours or 3 hours, so I decided to just break down all the topics and we'll focus on just animation nodes specific. So it's more on procedural animations, but I will point out some interesting things that I like about Blender as a tool for creating animations. And I really wish that I have Blender 10, 15 years ago, or even 20 years ago when I was still little and young and really get into animation. These days with computer graphics, especially big, like 15 years ago or maybe 10 years ago, computer graphics seems to be taking everything from flash animation and then 3D animations, and then everything has changed, and then now you have tools like Blender, and it's kind of nice. Anyway, before I go too far, our main focus will still be on animation nodes add-on, and procedural animation is what I will talk about mostly, and then our demo will be all this loop ping pong, switching on and off, and how we can control multiple objects, and then finally we will cover a little bit about procedural flipping. It's when you have like a mesh object in the scene, and then you want to flip the faces, kind of like the effects you've seen in the movie X-Men, where the character transform into another character. I forget the name of the character. Right, it's a morph, or yeah, I forgot. But anyway, we're gonna cover procedural flipping at some point, and I might have to create another video for more advanced procedural flipping. So let's start with showing you a little bit of Blender animation. So if you're like a total beginner, you're lucky to see this video, because I will kind of talk about the basic of animation using Blender and kind of showing you some introduction about Blender animation. So let's get started. So when you're animating in 3D, you will mostly be focusing on transformation of objects. So it's either location, rotation, scaling, and perhaps the visibility of objects. But even those transformations, you need a little bit of familiarity with how you move around in 3D, because you have like the axis, XYZ axis in position or translation. X, you look at this image here, this icon is displaying the axis of your object translation in X and Y and in Z, usually up and down. And with rotation also, you have rotate X, rotate Y, rotate Z, and sometimes with Euler, and it's called Euler rotation. And Blender uses also another rotation called quaternion. And if you're using Blender skeleton or bones or armature system, you will be using quaternion, but you also, for now, you just care about rotation XYZ. Later on, you might find when you're animating, the rotation might be flipping, and you find something that's called gimbal, and rotation order actually matter. So that's all important when you start animating in computer graphics. And you also have scaling, and all this you can animate. And for animating something, you will start keyframing. So in computer graphics, you will have similar terminology you have like in traditional animations. Traditionally, you will draw a keyframe. Let's say you draw something on keyframe 1, and then you go 5 frames ahead and then draw another drawing, and you're drawing frame by frame animations. In Blender, of course, you have that feature as well, and it's called grease pencil. Grease pencil is a way how you can draw something on screen, kind of like using your markers and drawing on screen and drawing it frame by frame. And grease pencil has been improved in a recent version, and I really like it. I even want to feel like go back to traditional animations a little bit, but of course, yeah, I was kind of, for the last 10 years, I kind of a little bit sidetracked, so I get more interested into more technical animations. Because for me, even though hand-drawn drawing like traditional animation is really still can be really beautiful, but it's kind of time consuming for me. So yeah, I found procedural animation will be kind of my thing. So anyway, if you're using Blender for the first time and you watch this video, you can explore something called grease pencil if you're more into traditional animation. A few years ago, you have something called flash animation, but you don't have it anymore. You have just maybe Adobe Photoshop or some animation tools out there. There's open tools that allow you to still hand drawn animations. But if you're like more into computer graphics and 3D animations, grease pencil is your kind of like your best friend. This is the closest you can have in 3D to traditional animation. So yeah, with grease pencil, if you hold D and draw something using your mouse or your pen tablet, and then you have like a drawing on top of your 3D scene. It's, for me, when I first used Blender, this is kind of a surprise for me. Oh, we can actually draw on screen like that, and it's actually 3D. That's kind of amazing. So it takes time to get used to it, but yeah. So you have that, and then if you can go to like a 10 frames ahead, and you can draw more, but I suggest you to enable the onion skinning. So that's if you're an animator, traditional animators, and started to use computer animations, you will find this terminology to be familiar. Onion skinning, you better have that on, and then you go to another frame, like 10 frame ahead, and then you draw another drawing. I'm just kind of randomly doodling at the moment, so it's actually 3D as well. And then you go another 10 frames ahead and then start drawing again. You can see the previous keyframe drawing. So that's keyframe animation, and it's actually 3D as well. So you can see the previous and the next keyframe like that. with onion skinning, and then grease pencil is really cool. You will definitely love that feature, but we will not gonna talk about grease pencil too much. There are some really good video tutorials out there talking about grease pencil. Back to our 3D objects, the cube right here. I will create a keyframe just to show you. So on a frame 1, here's this is the frame number. That's the frame number. You can go through the frame number using your arrow left and right. So on a frame 1, I will make a keyframe. I will just keyframe the locations, but you can keyframe location, rotation, and scaling, and there are actually 9 different channels. For now, we just worry about location, so it's gonna be 3 different channel or attributes X, Y, Z. So I'll keyframe that on a frame 1 keyframe. It's actually I. The hotkey is I for keyframing, but you can also use I to keyframe location rotation, location scale, location rotation, and scale, all kind of stuff, including your own custom attributes. For now, we just worry about X, Y, Z. So I made a keyframe on frame 1 XYZ 000, and then at frame 20 I move the object like 5 frame in in the Y axis, and then I made another keyframe, just 2 keyframe, and we have like an animation because what happened is Blender doing all the calculations and interpolate between the 2 values. So that's the only important thing for procedural animation. So that's the basic concept is you have 2 different value and you have interpolations, and in order to see that and it's really common in any 3D animation package like Maya or Houdini. So you have a keyframe, you can go to like a graph editor in Blender. If we switch the layout to animations, we have the graph editor here. And we can see the keyframe timing inside something called dope sheet. But I'm more interested with a F curve window here. Yeah, F curve. There's something called drivers, but don't worry about drivers now. Just the F curve. This is the graph editor in Blender. The graph editor. Okay. By default, creating 2 keyframes like that will give you this kind of interpolation. So it's more like it has like ease in and ease out. It's not a linear by default. Be careful with that. And I can tell because it's called Bezier here. It has ease in and ease out, but you can convert it into linear. Let's see, I probably just need to select all the keyframes and then change it to linear. Maybe it has auto thing. Okay, that's what I want. So it's a linear animation. It doesn't have ease in and ease out. It's just a linear value go from one value into another, and the interpolation goes within the time. So you have the time and you have the value that changing, which is the the Y location in this case. And in Blender you have like a few different interpolations, including things like back and bounce and elastics. So back is a cool one, so it's kind of overshoot and back. This is very natural, and Bounce is more like if you have like a bouncing ball, it's doing this kind of interpolations, and that's kind of cool that you have this, and you have also elastics, and you can have this, and even though you have only two values, you have all different kind of interpolations. If you're more like a traditional animators, but a computer animators, you might create all these interpolations and draw it manually using bunch of keyframes. So that's if you're doing it using manual keyframes. And later on, if you're further on in, if you're using computer to make animation, you will find out something like bones or skeleton, and then character, controllers, animations. If you are on that level, you will worry later on more about on the posing of the characters, and then further on worry about the character facial expression, etc., etc. I will not be talking about all those because it's gonna be taking forever, like few hours. So that's a keyframe manual keyframing, and you can see it visually like that. With animation nodes, it's kind of similar, but of course it's more like I said, when we are working inside animation node, it's kind of we are making a modifier. So in Blender, you also have like a modifier for animation. So let's say if our animation is just like a linear animations, Blender has some really cool modifier for animation. So this will overdrive or adding more details to your animations without you having to do anything. Let's say noise modifier give you the noise on top of your manual animations, and then or if you have like a step interpolation, also giving you like more like a step, like jumpy kind of stop motion kind of animation look. And you have noise, and then cycle is kind of like looping the animations, and you have this all for free, and that's actually really cool for animators. Now if I start a new fresh scene and I want to do the same thing using animation nodes, it's all there. I'll switch to compositing. It's all, everything you see is all there, but you're not keyframing as it's not as visual. It's kind of, everything is a little bit more abstract. In a way, you can control any value. You can drive. It's more like drivers, right? With a manual keyframing, you tell the computer, okay, you make a keyframe and you keyframe a value, and two different values you can interpolate using time. Inside animation node is the same, but you can drive anything with anything. So that's kind of the hard part, because you have so much control. Object transform, of course, this is the first thing you want. You can control this object, for example, location XYZ using time, for example. Let's see, time is a node. Time info. If you just plug in the frame into here, and then you will see the object traveling like kind of like a diagonally. No, actually it doesn't travel diagonally. I was expecting it to do it like that, but it's not, because animation node's kind of clever, and it creates this combined vector for you. Like I said before, location is a 3 different attributes, so it's 3 different channels, and you should be aware of that. And animating using animation nodes, if you're using the frame number here and animating the translate X, you need to use a combine vector for that. Combine, because this object transform output is expecting like a vector already. So either you translating the X or translating the Z or both at the same time or all 3. So it's totally up to you, and you can animate that way. And of course you can use things like math right away. You're dealing a lot with number, and it might scare you, but don't be scared, because like you will be using just a simple math mostly. Like here, I'm multiplying the frame number using value 0.1, and then see it's 10% like a slower. So you have that, and then you can, let's say if you're thinking, but let's say all I want to do is just to animate the cube translating from 0 to 10 in the z-axis. How can I do that? This is like, if I'm animating like this, it's kind of super confusing, you might say. So the cube doesn't have any minimum or maximum. So how can I kind of have that control? So in order to do that, you actually use something called map range. So the time value goes into the map range, and then the value goes into the Z, for example. And then here, it's only, you will see, oh, by default, it's like, it's only animating from 0 to 1. But you actually want it from 0 to 10, for example. So you specify 0 and 10, and then you test it again. Okay, it jumps from 0 to 10 within only like 2 frames. That's because of this input min and max. It can be like 5 frames, so it's the duration of animation. So you started to see your animation is kind of more visual, right? So, but you can also use interpolation here, and you might have something like back, for example. So let's say, okay, for your cube, you want it to go from 0 to 10, and the duration, let's say 20 frame. You can do that, and then you have that animation happening. So, and you have all these interpolations, but you can also draw your own interpolations using bunch of nodes for you here. Construct, there's also mix interpolation. Yeah, all sort of stuff, sort of nodes that help you to deal with interpolations. But on top of this, you also have something called animate. So I'm just telling you all kind of options you have inside animation nodes. So animate vector, animate Euler, quaternion, matrix, color, or number. So you have all this. Let's say, since we are animating 3 values, which is the locations, we can use animate vector. So we have this bigger node. This kind of does everything similar to map range, but it's kind of more compact. you can have the same result. And with Animate Vector as well, you can have like you can have easier control of when you start to deal with multiple objects. This is kind of more animator friendly, I guess. So the time, you plug in the time like normally. The result will be for the location. You have the start and end vector here. Start and end vector, so that's useful. So you say, okay, start at 000, you want it to travel to 0010, so it's traveling up 10 units, and interpolation is going to be linear, and durations you can control here, so you don't need to have like a like a remap. So you have the animations happening already. So that's another way you can animate. And you have, once again, feel free to try all of these. Animate Euler and Quaternion for rotations, and Animate Matrix for full transformations. Animate Color also works. And I haven't used this much, but it's actually really cool. And if you're using Blender, you make sure if you're using Blender Render and or Blender Cycles, there are two different render engine, and depending on which one, you have different way to do things. For now, we just focus on Blender Render, and for the material here, I just created for that object, and then I need to maybe enable object color. I tend to do that, or we can just animate the material diffuse color, whichever you like. Let's try material diffuse color for now. Copy the data path, and let's see, we're gonna animate the attribute of the object directly. So this is what you do. Complaining, diffuse color. That's the thing about the material. So in order to get to there, you need to know the exact locations. So it's actually BPY context object, active material, diffuse color, active material, diffuse color. So not very animators friendly for that case, because you actually need to directly point to the materials. That's why I rather use the object color, and that will you can control from here, so like that. And with object color, you just type in color, and so if we want to animate that object color, we plug in the result into there. Maybe starting red and then ending blue, and then plug in the time, and now we have objects that changing color from red into blue, and it's interpolating as well. That's probably, yeah, the basic is, they are really basic. I'm not trying to insult you if you're more technical and then you're thinking, what am I watching, this is all so basic. Because my target with live noding is, this is mostly for beginners to intermediate, because once you go to the advanced mode, you will go your own way, sort of. So there's okay, I will show you the looping and ping pong thing. Looping and ping pong, that's you can use because we don't have it in the interpolation. It's not really interpolation. It's actually more on the time itself. So if you're working procedurally, you will kind of create multiple time very easily using something called delay time. So delay time, later on, if we are dealing with multiple objects, we will use delay time definitely to kind of randomize the animations. So you have multiple time instead of time that goes from 0 to the end of time. You can delay the time per object or per component. Okay, with looping, you actually have a node called repeat time. Repeat time is very simple. So if you plug in the time there and then it's set to loop, it will loop. Okay, so that's how basic it is. Sorry about that. So looping time. So we have 250 frames here, and it's looping. Let's see if I can play back. Don't know, sometimes my computer is a bit slow. Okay, it's looping over and over again within 50 frames. It's kind of stopped there. It's kind of like a hold, which is nice. You can have like hold because I set the looping to 50 and then the duration of animation is 20, so we have some extra time to hold the value and then it's back. But we can also have 20, so it's looping like that. That's looping, and there's also ping pong. Ping pong will kind of loop, but it's back and forth. It's really nice to have this. You can have, even with such simple looping and ping pong, you can have beautiful animations, like beautiful motion graphics. That's something to keep in mind. Lamp switching on and off. Lamp switching on and off. That's actually when I should talk about drivers. So in terms of procedural animation, it's more like a driver where you can drive any value using any value once again. So we have this moving object, right? I'll just gonna leave them like that. But we also have, this is the camera and this is the lamp. I will turn on the lamp and see it in the scene. I'll have a floor so we can see the lamp, effects on the lamp. I switch to this texture mode, or maybe material. Okay, material is more clear. We have this lamp, and then the lamp has all these kind of attributes, and the energy is what I want to drive using the animation. So let's do that. You see the energy here, it can go from 0 to whatever value up there. We can connect, for example, we can connect the z value of this object. Yeah, let's investigate this object, but I will use object transform input just to be really clear. Object transform input, the input, and we will monitor this object, just the location. So, and the location is 3 values, so we're gonna separate it into X, Y, Z component. Here I will be really clear, so I will use a debug drawer. So we are monitoring, like I said, we are monitoring this object that's currently kind of looping like that. We are monitoring that object, so obviously it goes from 0 to 10 in z-axis. And let's have a look. I didn't lie, so over time, so our duration is 20 frames, so over time it goes from 0 to 10 and 0 to 10 again. And then when we're separating the value and monitor only the z, axis, we can see it goes from 0 to 10 back to 0 because it's a ping pong animation. I'm gonna save this real quick. Ping pong animation of the cube going up and down, and we can use this to drive our lamp, not in the transform but more on the, let's say, the energy in this case. And the energy itself, not the, yeah, the energy, we have the color. Maybe we will drive the color as well. Just drive the energy for now and make it go from 0 to 10 just like the z-axis. Okay, how do we do that? We right click and then get the data path, and we're gonna animate the attribute. This is kind of the thinking you need to have when animating procedurally in the basic kind of level. So plugin attribute not found, and yeah, once again we're stuck, but don't worry because we can check it out. Why it's not working? Because the data is, it's called data.energy, so not just energy. Once again, something to keep in mind. Now it's actually animating the energy up and down, following our our object right there. What if we just want to have like a, instead of value that goes from 0 to 10, we want it to just switch off on and off? And switching on and off, it's kind of like we need like a boolean kind of data. Boolean is either on or off, so boolean. That's a boolean on and off, and the value will switch from 0 to 10 because on and off is also true and false, and 0 or 1, or 1 or 0. True is 1, false is 0. So we can have control over the light switch on and off like that. But if you're asking, if you're like a curious type and you want to on and off the light using the position of this object, you can do that as well. So that's really how powerful animation nodes is. You have control over everything basically. You can use expression for that. This is also, if it is new for you, don't be shocked. So let's actually use the debug as well. It's not animation nodes that actually slow. This is my computer kind of doing processing in the background. I don't know. Maybe it's defragmenting. So we have the objects that's animating. With expression, we can tell, okay, if the object, let's say, just for example, if the z-axis, let's rename this variable, and let's say if the z-axis is bigger than 5, do something. So true, false, true, false. So we have that's happening already. So it's a boolean and it's working. And so we can do that real quick. So now if we play back our animations, somehow it's slow. Let's go to 3D view full, and we have our, let's have our timeline here. So sometimes this is really cool. So it's really fast like this. I don't know why. have our object moving up and down, and then let's have this and have the light switching on and off. It's working as we plan it. Probably the OpenGL is slowing down my MacBook because the graphic card is kind of doing a weird thing, must be. So back to compositing. That's switching on and off using animation nodes. There is also a switch nodes that you can use. So instead of driving the number using just true or false, you can use this condition, and you can tell Blender, okay, if it's true, turn the value into 10, and if it's false, back to, or maybe 1, and then you can plug the output into the lamp like that. Value has wrong type, true, false. Value has wrong type, it should be, okay, it should be float. Back, switch, if true 10, if false 1. This goes to there, and this goes to there. Yeah, it's a weird thing because it's a it's a weird thing about object attribute output. Just be careful there. It's changing the attribute slot depending on the data and the attribute, so it should be a float. Yeah, so that's wrong. That's wrong. Switch also. Float. Yeah, so that's the energy is a floating value data. So in order for this to work, it needs to have a correct kind of data and value. So value has wrong type. Maybe it's a bug. It's probably a bug. To be safe, we just do it like this. So depending on the position, it will change the value either between these two values. So those are important as well. So see if you can also change the color of this lamp to follow these objects. That's a homework for you. Let's quickly create a new file. Cube and many cube scaling. So we are now starting to cover something that's more interesting, and this is actually more like that. Driving polygon faces, procedural flipping. Eventually we get to the procedural flipping, the cool technical stuff, but for now just a cube. We have this cube object, and then let's see, we're gonna scale this cube using time. First of all, let's see, switch to animation nodes, compositing nodes, and we don't need this, so just a cube. You can use object transform output, you can use objects matrix output, or you can use the animate vector. This is more, like I said, this is more animators friendly. Start frame 1, frame, but you can do it either way you like. So we can transform this object, that object, scale. Okay, so can you understand what's happening? I wasn't explaining. So this object is being controlled by object transform output, which is the value of the scale we get from the animate vector with the time input, and the duration is 20 frames. So to summarize, it's a 20 frame animations of this object scaling down, okay, from scale 111 to 000, and it disappears. So that's gonna be our animation nodes demo for today. But the cool thing, of course, with animation nodes, of course, the cool part is you can drive many objects like a conductor. Yes, so that's actually the important part. Say I have multiple objects like this, and then I want to animate the scaling like that, just the object disappearing into nothing. How can we do that? So this is really basic, but again, if you're using animation nodes for the first time, or even you're using it for a while and you still don't know how to scale these objects together, this is how you can do it. Just one way you can do it. So the way I like it is to use a grouping. So I group the objects, and then I quickly group. Oh, wait a minute. Before I show you the object grouping, there's also something funny called get selected objects. This is actually kind of live. I found it's really funny in Nodes because it's a kind of like a real-time thing. So we have that object disappearing, but instead of that object, let's see, should be careful with this because it's kind of, I said it's a funny node because it's kind of doing it real time, and you have to be careful when it's doing it like that. With this object, you can actually select object in real time, like kind of like you're manually doing it, but with all this automation going on. So be careful, but you can have like multiple objects. Maybe you have like multiple lamp and want to change the energy, and you can use this get selected objects. So this is like kind of live. So if I plug this into that guy, I can basically scale it down without touching the object. Or if I have multiple objects. So see how scaling down. But there's of course some complexity going on, so it's only reading the time. It doesn't have delay, and well, don't worry about that. This is a funny node. I might have just one video tutorial just talking about that node, but for now we're gonna scale back all our object back to 111. So we never want this kind of thing to happen, okay? So at the moment I have the object kind of scaling to 000 and we cannot see it anymore. If you're animating procedurally, you need to be careful not to have that kind of effects, you still want to control the objects, and if you switch off the control, you want the objects to go back to default. So that's one thing to keep in mind. So back to where we were, we have a bunch of objects and we want to animate them all at the same time. For example, how do we do that? Like I said, I use grouping, and then I use objects from group node. This is very important. So now the animation nodes knows we are selecting bunch of objects, and we want to iterate, loop over each one of them, and then scaling it down. I will tap W, loop through objects. Now we are looping through each object, and for every object, every object here, we're gonna scale it down. So now we can see it happening. I will actually turn on the looping for now. Just repeat time. I'm gonna loop it over 20 frame. So duration 20 frame, our object kind of start from 111 and then disappearing to 000 and then back to 111. And we have all of them happening at the same time. Here we get to the point, another important point. In order to stagger, you need you can use something called time delay. So okay, this is how we get started. Bunch of objects, and we put it into a loop, and the loop will process everything at the same time. And you use delay. If we use delay here, delay time, we can kind of have like a more like stagger kind of effect. You will see it real soon, don't worry. Should we have loop? Okay, keep the loop for now, but don't worry about this too. We just worry about the output of this loop. Put it into time and then delay it using the index. That's the first thing you need to know. So now it's kind of delaying it by 1 frame. You can't really tell, but if I use math, oops, not vector, math, and delay the time, multiply delay by 5. Hopefully, okay, the time should go actually to there. Now we can see our objects kind of scaling down, but we have kind of like a stagger kind of effect. The loop is kind of making things a little bit complex, so I get rid of it for now. So we have time goes into delay time, and the object disappearing one by one. Okay, that's first lesson for you. So delay time is useful, and in this case we are using the index, because the index is good because it's reading into the list and can see the order of the list, and then we can animate over it. So that's cool. You might wonder, you might think, hey, but what if you want to kind of animate them like having more control on which one disappear first? How do we control that? For that, you will need to use something called sort. So the list become really important here. There's a custom. I'm not familiar with the custom yet, but there is so this is our object list. We can, if we plug in the list, this sort list will check this list, and then okay, you basically can use the name, you can use the point distance, you can use direction or the key list. Start with the name first. So with the name, So depending on the name of our object here, the default is cube, just cube, and then cube 001, 002, 005, whatever. If we are sorting the list by name, we can now can see the object animating one by one through the list. Okay. We can also use direction, say with the direction of the x-axis. So x-axis, we can stagger the animation like that. Okay, that's very cool, really cool actually. Another one is if you use a stagger by point position, point distance. So that's also really useful. So depending on the points, let's say if the point is at 000, it will stagger the animation like that. So depending on which object is closest to the points, or if you have that empty object, let's grab the empty object and grab the locations. Depending on the position of the empty, whichever object that's closest to the empty will disappear first. So that's also really powerful. Okay, so another concept for you to understand. It's really basic, but yeah. Ping pong done, light switching, drivers, and then matrix and pivot. That's when we are dealing with rotations. For now, I'll skip that. We're gonna do, let's say, procedural flipping. Yeah, that's probably the next thing I should cover, just to close this live noding of procedural flipping. It's such a classic example, but you will see that it's not as simple, but not difficult either. So I don't know how to explain it. Once you know all the concepts, the basic concepts like delay and time and how you can drive any value with anything, and you can work with multiple values, this is actually quite simple, but you have some complexity on top with the pivot. If you're flipping is like rotating, right? So how do you want it to flip? You can flip it in so many different ways, right? For now, let's just scale down this object. For every face, you will scale it down one by one. How are you going to do that? Yeah, let's have a look. So you have this grid. I use grid because it has by default it has 100 faces. 100 face, and you're gonna work on each face. You're gonna animate each face. You must be crazy. So how am I gonna do that? It's actually quite simple, because we have the node that does it, so we're lucky. We're gonna be dealing with the mesh data, so let's get our object mesh data first. So object mesh data, right? Let's grab our object, is that mesh, is the grid. We're gonna modify the polygons face, so it's each and every polygon. So with object mesh data, it will already, we have control over the polygons, sort of. So hit W and we're gonna, okay, loop through polygons. Don't be scared, this is maybe shocking for you that we can now have control over the polygons. But even this is not quite simple yet. We're gonna have to transform the polygon. So transform polygon, it's object, and transform polygon, and then polygon output. So this is kind of the setup that you need to do, the most basic setup. Okay, polygons, like a mesh data of these objects, which is the polygons list, goes into loop. This is as simple as it gets actually compared to other 3D package. This is really simple, okay? And we want to scale, so I'm gonna use compose matrix, but don't use compose matrix, just use a scale matrix for now. So that's simple, okay? Don't overcomplicate yourself at the beginner, for the beginner level. And we want to have object output, mass object output. Okay, mass object output, we're gonna create a target object and then plug this in, and then finally, okay, we have our stuff happening. So we have our original object, which is this grid, and then we have this animation node set up, and we have this target object. So we will always have this kind of a original and a ghost, original and the final result. Okay, this is important for now. We're not modifying the original. Maybe you can, but don't worry, because usually what's more interesting is the result, and that's what people are gonna see. What's the audience gonna see? As long it gives you the illusion, it's fine. Okay, you can cheat. So that's doing the scaling. Okay, that's how simple it is. Once you have this set up, you can scale down the scale like that. So if you want to kind of stagger and have the effects, scale the face one by one, how are we going to do that? Now you suddenly have another problems, but don't worry, it's actually quite simple. You might have headache how to understand this at first, but this is actually quite simple. Once again, once you understand it, okay. So we're gonna scale the matrix. We can use the okay, let's use the compose matrix. Compose matrix scale. Since this is just a scale, we just use a animate vector. Okay. Animate vector, and once again I will scale the matrix. Scale the matrix. So the scale goes from 1 to 0. You have seen this before. We're gonna use time to control our animation time, and the result goes into this guy. So 20 frames, maybe make it 50 frames. Offer the duration of 50 frames, our object scaling down and disappear. Of course, we can now use the time delay. The delay time, and stagger the effects. Okay, stagger the effects. So cool. So it's already working. That's 100 offer times 100 phase of objects disappearing. So I think that's really cool. So normally you're not able to do that so easily. You can use like a different object to start with, and then have the effects happening before your eyes. So yes, that's really cool, and then it's so simple, right? Just now I might have I must have accidentally did something weird, like a loop. So be careful. Let's go back to our grid, create a new target object, put it to the side. Okay. Normally you will hide the original object. And of course, the cool thing is you can sort the polygon just like before. You can sort list and sort it by, let's say, direction. So it's by the Z direction, or we can reverse it. Z direction, that's actually more like Y. So Y direction, maybe Y and X. Okay. Very cool effects, and it's pretty easy to do. And if you wanted to, instead of scaling, if you wanted to flip, okay, flip is a little bit more complex, but it's still basic. So instead of scale matrix, you want to flip matrix. Okay, matrix, rotate. Do we have Euler matrix? No, we don't have it. Matrix, decompose, compose, translation, rotation, probably rotation. Matrix rotation. Okay, maybe you want to rotate it like that, using the center as the pivot. If that's what you want, you probably already have it, although the angle is kind of Euler. And another problem, but it's actually simple, we're gonna use animate float and plug in the result there. We actually, because the angle is in the radian, we're gonna need it degree to radian, yes. Time goes start, animate start, it will end at 360 for a full flip, or maybe 180. And the time comes from the delay time, and let's see what happens. We have our procedural flipping happening. And if you don't believe me, this is actually flipping. You can use Solidify. And Solidify is cool because we can colorize the rim and stuff. So it's this is like the basic procedural flipping. Okay, don't expect much. It's supposed to be simple, but even this is quite cool. The effect is quite cool. Use that and create another material, give it a blue color, so 3 different color. That thing's flipping. The blue is actually the thickness, so yes, so like that. Normally I'll just, let's say for, okay, the edge is gonna be just yellow. So this is simple procedural flipping. You have control over a lot of things here, okay, including the the way it's staggered. But here we're actually using the index. Yes, maybe you want to flip it another different way where it flips like a row by row or something. That's also a different set of problem that you can find out yourself probably. But you can use like a displacement modifier for that also to have even more control over this flip. Yeah, so I guess that's how it's the simplest flip that I could show to you. There's of course like a more advanced kind of flip. Like with this flipping, it only works if the square is kind of the same size, because object doesn't flip properly if you have different size of face. Let's try this torus, for example. It's still flipping, but it's still pretty cool. But the pivot, you need to worry about the pivot of its faces, and for that's gonna be for more advanced flipping. But this is still kind of a cool trick you can do. And then if you want a full flipping, you can do it like that. Full flipping is funny. Of course, you can use interpolation. So that's the whole basic concepts you need in order to do flipping, and then have a kind of cool overshoot, and then you're animating procedurally. And yeah, so hopefully you find these video tutorials useful. Please do subscribe for the channel. I try to hit like 1,000 subscribers. Hopefully you become the first 1,000 subscriber. And yeah, thanks for tuning in at BLENDERSUSHI live noding. Yeah, hope you find this video useful. Enjoy all the techniques and try it yourself and see what you can come out with. You can comment or send me a message if you have questions.